Yes.
The screen, okay. So this is the place for this documentation. So you can go to this website, docs.hpcwbu.edu. We have all that we will show today will be right here. So what's the idea? We have what we call a high-performance computing cluster. So this is basically a big architecture is built with many computers all together, and many people access those. But typically for big executions, big simulations. But what we will be showing today is using this facility, this infrastructure, for interactive scientific computing. Pretty much the kind of computing that you expect to do from your desktop computer. But at some point, your computer is not powerful enough. It doesn't have enough memory if you are doing, by the way, what is your area? So I can, which is your area of research?
Biology. Genomics.
Genomics. So this is a perfect example. This is a perfect example because it usually is the case that you don't have enough memory on your computer, on your normal computer, for doing alignments. This is, so it exceeds by far the amount of memory that you typically have on a normal computer. You have 8 gigabytes, 4 gigabytes of RAM. So you cannot put all those pieces in order to do alignments or doing the population genomics or whatever you would plan to do for your research. But on our machines, the smallest compute node offers 92 gigabytes of RAM. So that's one order of magnitude bigger than a normal computer. So that's the reason for doing this. So for doing interactive scientific computing. So the idea is to treat a computer like your handheld calculator. You just execute some commands and you are in front of the machine, in front of the computer, and you see those commands being executed and getting the result back. There are basically 2 ways of accessing the machine for doing this. The first one, this is the dry way, is to access the machine from the terminal. So this, let's say the traditional way, and I will be jumping here and trying to do it for you in real time. So let me go here, clean this environment here. So I will be sharing instead of this screen. Maybe let me see. Let me leave this. So have you ever entered on the cluster before? Are you ever? Okay, so at least we can start from here. Somehow you connect with instructions that you know for accessing the cluster with SSH, and you land on this terminal that you see here. So you know that this is the head node because it has a name like this. This is the head node.
Okay.
So the first step for interactive computing execution is to request an interactive session. This is the simplest way of getting this. You execute this command.
I can't see the command.
No. Maybe the screen is what? What about if I change this way? Can you see the command now?
I can see halfway.
Okay. Let me go up here.
Now I can.
And if I execute it this way, can you see this?
Yes.
Okay. Okay. So this is the command. This is the simplest way. You enter on the cluster, on the head node of the cluster, and you execute this command. You notice that you jump into a different machine because you are no longer here. You are here. This is a different machine.
Okay.
When you execute this, by default, with this very simple command, you get 1 node, 1 core, and 4 hours for executing your job.
Okay.
So this is the most basic, the simplest way of getting into the machine. From here, you can do whatever you want. If you are doing alignments, you can just start loading modules or entering Conda if you have a Conda environment for doing that and executing the code. There are a couple of environments that you can use if you are interested in a more general interactive computing, and I will share with you 3 ways, basically. One is this one module, for example, module load lang Python, SciPython 38. Let me see this one. We have this involved, IPython. For those who program in Python, and or if you have something that works on Python, this is an interactive environment, perfect for that.
Okay.
This is one alternative. So b equal 4, a plus b, and you execute. If you are loading a module and it's doing something, you can do it this way. This is for Python. Another alternative is R. So let me clean the modules, purge, and module load lang R, let's say 4, this one. And this is here, we have another environment for executing in R.
Okay.
So the same thing, pretty much, well, usually it's like this, like this, same thing. Let's see. And this is from R. Finally, you can use MATLAB. MATLAB is a language probably not so popular in your area in biology, but for engineers, it's very popular. So that way is, okay, let me clean modules, purge, module load, lang, GCC, equal to, and MATLAB 2020 B, and MATLAB no desktop. And you access the MATLAB environment. You are by no means forced to use those environments. You can just use the terminal and execute your alignments or whatever you want to do with for genomics from the terminal, from the command line interface. So it takes a while with MATLAB, it's always the case, but you will see. See. Okay. So pretty much this is MATLAB.
Okay.
So this is, well, I think it's exit or quit. I don't know. Oh, yeah. Okay. This is how you access interactive computing from the terminal. Not sure for your case, but I will just show you another thing. It's if you want more cores, could be your case or not, nodes equal to 1, ppn equal to 4. And that way you are requesting 4 cores. The ability, yes.
Sorry, can you please clear your screen again?
Yes, so I will be, let me see, exit here, and here I clean it so you get it on the top.
Yeah.
Okay, so with this, you get 4 cores for execution. It doesn't necessarily mean that your code will be able to use those 4 cores. It all depends if you the software that you are using directly or indirectly can take advantage of those 4 cores.
Okay.
And on Thornyflat, you can use up to 40 cores.
40?
Most of them, 40. So at this moment, you get 40 cores. There are programs like BlastP or something that you can use 40 cores, but you have to explicitly say that on the command line that you want 40 threads. That's you have to be explicit on that. I think for population genomics, I think Stacks is also able to parallelize some things. Blast, I think, do that too. Not all bioinformatics codes are able to work in parallel. So be aware of that, that just by requesting 40 cores doesn't mean that your execution will be faster, automatic. But it could be. It could be if you are using a software that is able to take advantage of that.
Okay.
Now, finally, let me see how I can get this. You can also request, this is GPU inter machine with GPUs.
Okay.
Again, not very often in bioinformatics, but that is changing now. Let's say, imagine, are able to use GPUs, take advantage of GPUs for performing calculations faster, or take advantage of those devices. But if you are in that in that area, and you know that your software can use GPU somehow, you can request those this way. Maybe the name.
Just a naive question, Guillermo.
Yes.
Like, what is a GPU?
Okay, GPU is, so on a normal computer, you have the CPU, the central processing unit. But there's the kind of thing they tell you when you buy the computer. They have them Core i7, Core i5, blah, blah, blah. That is the CPU.
Okay.
But for people who can, there are some devices, external devices, so cards that you can attach to your computer, to a desktop computer usually, but also in some laptops, high-end laptops, they come with that. They came with that, what is called a GPU, graphic processing unit. So that GPU is an external card that originally was intended for gaming or for 3D visualization or all that thing. But the kind of operation that those cards are able to do fit very nicely on certain kinds of workloads, executions. So you can use those cores for performing calculations that they perform very well on those devices. Typically, people who are doing classical molecular dynamics are able to take advantage of those. People who do image processing sometimes are able to use those things. And they are very, very popular for machine learning, for what is called neural networks. So algorithms that mimic the behavior of a neural network. So the biological neural networks translated into an algorithm. So for those use cases, GPUs, those extra cards, perform very, very well. So people use those cards in those environments, or for those kind of needs. So the it's GPU inter VPN. Oh, maybe GPU. Okay. Now I'm not sure how easily I will get this. But yes, so this is how you request a GPU for interactive computing from the terminal. Okay. So, but again, Uh, it will probably take some time. Now, what I will show you now is an alternative to that, is how to access interactive computing from a web interface, which is appealing if you don't want to enter too many commands on the terminal. So for that, I will be jumping here into this one. Here. So how you access this? Okay. The first thing is you on your web browser, and you can do it right now if you want. You open the web browser so you can type this and see that interactive. I will give you time. So, so we have a couple of people, so you can both interact and ask questions and at any time. It's perfectly fine for a couple of people. So you enter on this website. OnDemand is on top. Can you see this clearly? The web, the image. So it's ondemand-tf.hpcwvu.edu.
Yeah.
Okay. See, let me see if I can. Otherwise, I can copy and paste this here.
I put it in the chat already.
Okay, it's in the chat. So this is the website. When you enter there, you will be asked for your credentials. The Duo, you enter your username, your password. That will go into asking for your phone, and you from your phone you acknowledge, you accept the Duo, and you land here. You land on this dashboard, on this screen. So are you here?
Yes.
Okay, so now this dashboard offers you a variety of options for interacting with the cluster, with OnDemand. One is here to request an interactive execution using a Jupyter Notebook, for example. So here, you click here, interactive apps, and you click here where it says Jupyter Notebook. So, and you get this form. For most part, you don't have to change much. Here, for example, I'm selecting the Python. This standby, by default, it's standby. I will be requesting 1 hour. You can request up to 4 hours with the standby. So the wall time for execution, how much time do you want to use this? With the standby, you can request up to 4 hours. So let me see, I can request the 4 hours. How many cores do you need? So I'm asking for 8 cores. You want to use a GPU card? Yes, no, I will say no. Jupyter and launch. Are you able to reach this point?
Yes.
Okay. Any trouble? So Jupyter Notebook, you should be here. So try to mimic what I'm selecting.
Yes.
So let's summarize. So I click here, so interactive apps. I click here, Jupyter Notebook. So I'm here, Jupyter Notebook. I select this CPython 3.8 for the Python version. Standby, 1 hour. 4 hours. 8 CPU cores. No GPUs. You can leave this open or not. It doesn't matter much. Jupyter, and execute and hit here, launch.
Yeah.
So when you hit launch, you land on this web page. Well, it's asking you to wait for a few minutes, typically just a few seconds, actually. And it will start your job. All that I did before from the terminal is actually happening behind curtains. And you get just a button here which says connect to Jupyter. I hope you have something like this.
Yeah.
So in this case, I ask for one node, 8 cores, 4 hours, and I get connect to Jupyter. So from here, you can create a new Python notebook, and you can start executing commands here. So if you are using a package that is written in Python for your research, that's one way of playing with that. So something I will do is something very, very generic. Matplotlib. So that is not specific for biology, but anyway. Matplotlib. Actually, what I usually do, plot of import. So actually, so just a couple of commands. The good thing is that you can get the plots on the web interface. You can see the plots, which is very nice. And that's it. You can create a notebook that pretty much reflects your execution. Actually, you can convert this into a research notebook, very similar to the research notebook that you have for experimental matters, where you are describing your standard, the different conditions that you impose on your experiment, all that, and you can convert this into a research notebook. So you can put a title, and you can convert this into Markdown and start building this as a notebook where you can reproduce all the steps that you are doing with the data on a notebook that you can save. You can export this as a PDF, and you have something physical or something that you can follow and present and all that. So that is one way of working interactively from the web interface. At this moment, you are using 8 cores on a compute node. You can request the 40 cores, and at that moment, you get the entire machine, so you get 92 gigabytes of RAM up to 4 hours.
Wow.
So that's one way. An alternative to this, just to go, is I can also click here for those who work in R, and there is also packages for R. There are also packages for R in bioinformatics. I remember at least one that is called Bioconductor, if I'm not wrong, and that works on top of R. And in this case, when you hit here, RStudio Server, you hit RStudio Server. I'm selecting this ARS 4.04, and I hit launch. And same thing, I get this on this place of the web interface, which is asking me for a few seconds. Again, you get a button here, connect to RStudio Server, and you open an RStudio environment. Now, where you can hit commands. So actually, So actually, I already have the commands there. So it's testing this up. And same thing if you want to execute things, packages that were written in R. So here you can see the packages that we have. You can install packages. I can show you in a minute if that's of some interest to you. So I have here bio. This is bio. What's the name of this? Bioconductor is right here. So the package manager. So you can install packages that is specific for research in bioinformatics. No problem about that. And this is another environment. And what else? So here, and also you are not constrained to just running on a single environment or single job, interactive job. Here I have two. I have this one here, RStudio server, running RStudio, and here, this one running Jupyter. And I have both running, and I have both running for up to 4 hours. So the time is running here, so it will tell me always how much time I have left on those 2 jobs. But there are more things about. You can also access like a file manager, which actually is looking into the files that you have in your cluster, which is very nice if you want to see an image or something. I don't know if I have an image to show you. But at least I can show you a text file. So you can see the text file. So if you are executing something and you get the results or a summary of the results, and you want just to see the output of that file, or you just want to see the file somehow. So what do I have here? So, okay, the comic that I use for a presentation. So you can see images, you can see text files, all that on this environment. So I access this environment here on the dashboard under files. There's another thing that I have. You can also access terminal interface that land here. And I can execute commands here if I need something. This one is running on the head node. So here I can install packages without any problem. On the contrary, on the compute node from here, for example, if you are here, you cannot install new packages. You have always to install those new packages here from the terminal. But no problem about it. And also, if you are running jobs, multiple jobs, and you want to monitor those jobs, there is also a job monitor that show you the status of those jobs. So here you can see the jobs running. If you are running interactively and you just want to monitor how much time you have left on them, or a couple of things actually on the specifications of those jobs, you can do that here on this job manager somehow. And what else we have here? So okay, there is also an alternative images here for Jupyter that you can access. And those are more for deep learning, for neural networks. There is one for R here, and this one for data science, stack of packages for data science. And this one for, again, data science, but mixing Python, Scala, and R languages, and Spark for big data or that sort of execution. That's what we have actually. So if you have any question, I can dig more into a specific topic or a specific thing that reflects what you are planning for your research or what you are thinking about.
So for I don't know whether you remember or not, like you helped us create a singularity container with many softwares, bioinformatics softwares. So if we are using that singularity container on the interactive computer,
Yes, it will
so
be right here. So
yeah.
for that specific case, and I create an environment. I think I remember when you asked for that. So it's right here. So you first you enter here. This is the dashboard. So hit here, here, Jupyter Notebook, and here, instead of selecting a specific version of Python, you go here and select Python via Singularity. This is one thing. This will be the same, 4 hours, this. And down here, you select this Python and this Singularity container that I create for you for this initiative that about teaching people about bioinformatics and all that. So this one, bioinformatics, I create this Singularity image and I call it Bioinformatics 2021. And the idea is that if you want next year, I can create Bioinformatics 2022, and we can start moving with that, updating the stack or those packages. And here you just hit launch. It will be right here. So I can show you what we have, the packages there, and there are a few caveats. I really don't remember exactly, so it will be this one. And here we have, let me see, a Python interface. I don't remember exactly which packages from the list that you sent me work on Python. I don't really remember. I know that there are a few that work from Python, so I'm not super sure which one. See if I can see something here that strikes my eye exactly the same. Otherwise, I can see from the list of packages and the let's see. Nothing.